Alrighty, guys, I'm gonna get started. Hopefully everyone is gonna join us soon, but I'm gonna get this show on the road. So remember what we have been talking about so far is sequences and series. We have looked at quadratic sequences, arithmetic sequences, and geometric sequences. And then last week, Wednesday, we started speaking about series, where we are now adding terms together of a sequence in order to figure out its sum. That's what a series is, the addition of terms. So on Wednesday, we spoke about arithmetic series, and today what we're going to chat about is geometric series. And this is going to lead us on into Wednesday's lesson, where we start seeing that there are certain geometric series that when we add their terms together, something quite cool happens. And we're going to explore that a little bit more on Wednesday. Right, but for now, we're just looking at geometric series. How do we add terms of a geometric series? What types of questions am I going to be asked? So before we get into our examples and our questions that we have, there's a few things that we just need to bear in mind and that we need to remember as we go along this journey with geometric series. The first thing is that any geometric number pattern has that constant ratio. Now remember, your constant ratio is the R value in your formulas that we work with. And in order for us to work out, or in order for us to determine an R value, what we need to do is we need to have term 2 divided by term 1, or you could have term 3 divided by term 2, etc., etc., etc. Okay, as long as you've got two consecutive terms, you can find your ratio. So that's the first thing that we need to know. The second thing that we always just need to bear in mind is the formulas that we do know that relate to our specific sequence or series. So thus far, we know Tn is equal to A times R to the power n minus 1. And we know that A is your first term, and R is that ratio that we've just spoken about. And this is important to remember because even though we are doing series, even though we're adding together the terms, it doesn't mean that this formula is no longer useful to us. It definitely is, depending on the type of question we get. And so we always need to have it in the back of our mind because it could potentially be, like I say, useful as we start to go along, and you're going to see that a bit later. So that's what we know. We should know all of this. Remember, guys, this formula is on your formula sheet, and on the Google Classroom, I've uploaded like a breakdown of your formula sheet in terms of highlighting your different bits of information that you've been given and saying, this is for sequences and series. This is for trig. This is for analytical, etc., etc., etc. The thing that we don't yet know, obviously some of you have already done this at school, so some of you do know, but assuming that this is the first time you've ever heard of a geometric series, the thing that we don't yet know is our sum formula. Now, the sum of a geometric series is A times R to the power n minus 1 all over R minus 1. And this is the formula that we're going to work with a lot this evening. Again, it's on your formula sheet. You don't need to memorize it. If you feel you want to memorize it, by all means, go for it. You don't have to, but it is there on your formula sheet. And remember, guys, this Sn means the sum of your series. So if we had S of, I don't know, 70, it would be the sum of the first 70 terms in the specific series you're talking about. Right, so these are all things that we should know or that we're going to learn about, especially this last formula, and we're now going to put this into practice. So I'm just going to wait here in case anyone does want to screenshot all of this. Otherwise, I'm going to go to example 1 and we're going to have a look. Alrighty. Sorry if you heard that. It's a massive shift. Okay. Right, let's have a look at example 1. So we have got evaluate 1 plus 2 plus 4 plus etc., etc., etc. to 10 terms. So firstly, when it says evaluate, this isn't anything that we need to stress over. It's basically just saying calculate the sum or calculate the value of. Just means calculate. So evaluate 1 plus 2 plus 4 plus blah, blah, blah means find the sum of 1 plus 2 plus 4, blah, 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 of this geometric series to 10 terms. Okay, so that means we're going to have to use our formula that I've just mentioned to you, and I'm going to write it down a few times, so it's going to eventually stick in your heads. There it is again. And remember, for us to be able to use this formula, we need 2 bits of information. We need A and we need R. As long as you've got those 2 bits of information, we are going to be fine. A is your first term, so that's what I have. No stress there. I've got nothing I need to worry about. That's right there. But R, we need to go and work out. Now, this is quite an easy R value. You don't even need to show this ratio because it is quite easy. But it would be term 2, which is 2, divided by term 1. And so your R value here is 2. It would be the same if you said 4 divided by 2. You still get that constant ratio, which is why it's a constant ratio. So we have all of the information that we need, and we can go and substitute into our formula. So I want the sum of the first 10 terms, which means I've got A, which is 1, open bracket 2, because that's R, to the power of 10 minus 1, all over 2 minus 1. Now, guys, this 1 in front of that bracket actually does nothing, because 1 times anything doesn't change the value. Obviously, you leave it there, it's absolutely fine. But because you've now substituted in everything, all you do is you put that into your, and you said into your formula, into your calculator, and you get your sum. And in this case, it's 1023. If we add the first 10 terms together, that is the sum that we end up getting. So really, when it comes to the sum formula, actually with all of our formulas, once we have all the information we need, it's really not hard to go and solve for what we want. As with everything in maths, we have to read our questions carefully, because as you see, as we start to move on in complexity here, we don't read the questions carefully, we're going to make an oops. But once we have our information, it's as simple as subbing into a formula and solving for our unknown. All right, so I'm going to do example 2, and then I'll make it a bit smaller for you to screenshot both. Example 2 is saying find the sum of the first 12 terms of the series 2/3 plus 2 plus 6 plus blah, blah, blah. Now, this question is asked a bit differently because it's telling us we want the first 12 terms. It's not using that evaluate phrase, but it means exactly the same thing. We're doing exactly the same thing. So remember, A is your 2/3. We do need to go and work out R because it's not as simple this time. Now, tells you've got options here. Remember, you can either say term 2 over term 1, or you could say term 3 over term 2, etc., etc. Now, term 2 divided by term 1 would be 2 divided by 2/3. That's fine. You have a calculator, you type it into the calculator, you get your answer. But you could also have term 3, which is 6 divided by term 2. And that's much easier to see that your common ratio, or constant ratio rather, is 3. It makes no difference though. Because it's a constant ratio, you will get the same answers. So 2 divided by 2/3 is 3. 6 divided by 2, we know is 3. So that's why I always say to you, it doesn't matter which terms you're dividing, as long as you're keeping them consecutive. Term 2 divided by term 1, term 3 divided by term 2, etc., etc. So if you can easily see that your common ratio is 3 by rather looking at term 3 divided by term 2, fine. Whatever, it makes no difference, you will get your answer. However, we now have A and R, which is all we need for our sum. So the sum of the first 12 terms is equal to 2 over 3 times R, so times 3 to the power 12 minus 1 all over 3 minus 1. Now, girls, please just be careful when you do go and substitute this into your formula, because obviously now you've got a fraction in a fraction. So just be careful when you do put it in on your calculator. You shouldn't have a problem, but just be mindful of it. Alrighty, so chuck that into your calculator. In the chat, let me know what you get as your sum. Oh, excuse me. Yes, like I say, let me know in the chat what you get as your sum once you put that into your calculator. And guys, you can write your answers as fractions or as decimals. It really doesn't matter. Both are fine. One answer, grade 12. I refuse to believe that. All right, I'm not too sure why we're not volunteering answers, but that's fine. What I do just want to do is I want to do the substitution on the calculator with you because of the answer I did get. You just need to be careful. So let's just open the calculator. Oh, God. Okay, so if we have a look at our calculator, there it is. We are substituting in our formula. So we want to have our fraction. Now remember, you've got a fraction in a fraction. So 2 over 3. And then we're going to open our brackets. 3 to the power of 12 minus 1. Oops, let's try that again. Minus 1. Close our bracket all over 3 minus 1. So be mindful of that when you type it in. And we get this 531,440 over 3. If you want to make that a decimal, 177,146,67. So please just be careful when you do sub in and type it into your calculator. That fraction within a fraction can get a bit tricky. And just be careful because in our original sequence that we had, our original series, which should be coming back to you relatively soon. There we go. In our original series that we had, our very first term was a fraction. So that does give us an indication that even though we're going to add a whole bunch of whole numbers, my answer should have a decimal to it, all right, because of that 2 over 3. So when we go and sub that into our calculator, as we just saw, we get that 531,440 over 3. Or if you want to write it as 177,146,67, that is absolutely fine as well. Remember, both are fine. You will get full marks for both. No problem either way, whatever you prefer at the end of the day. Alrighty, guys. So that one, not tricky, just be careful of your substitution. All right, so I said I'd let you screenshot the first 2. So I left my answers as fractions in this case, but I will do the decimals just so that you can see. So for the easy question, your R value here was 3. And so you had that. You also had your A value. It's given to you in the sequence, 2/27. So just be careful of that when you substitute in. And so our answer here was 19,682/27. That as a decimal, which like I say actually makes a little bit more sense, is 728.96. Both of them absolutely fine. Both of them will get you full marks. Right, if we jump over to the medium question, your ratio here was -1/2, so just be careful. And so what ends up happening, you've got quite a few fractions in the fraction because of that R value, but your final answer is -341 divided by 8 or over 8. That as a decimal is -42.63. Just be careful that the whole decimal is -42.625. This 5 rounds the 2 up to a 3. And so just be mindful of that when you are rounding off, because we should round off to 2 decimal places all the time. Right, so those are your 2 answers. I'll just wait here in case you want to take a screenshot, and then we're going to have a look at another example that's a little bit harder, and we now need to think a little bit more about what we're doing. Alrighty, let's have a look at example 3. Whoops. So if we now have a look at example 3, we've been asked to calculate the sum of the following finite geometric series: 0.25 or a quarter, plus a half, plus 1, plus 2, plus ... to 256. So there's a couple of things we need to take note of here, grade 12. Firstly, finite means it ends. So this 256 is the last term of this series that we are working with. It doesn't go beyond that. That is my last term. So when we want to find the sum of the series, the problem is I don't know what that last term is. Is it the 27th term? Is it the 12th term? Is it the 721st term? Which term is it? I don't know. So I don't actually know how many terms are in between 2 and 256 in order to add them together. And so we just need to read questions carefully when we do get them, because like I said, I'm not going to necessarily break this down for you and say, work out how many terms are in your series, then go work out your sum. I could just give you this, and you need to see that because I haven't told you how many terms you're adding together, that is the first thing that we need to go and work out. So the first thing we need to do is we need to determine how many terms are in the series. Now, we're told just because this is a series doesn't mean that you are restricted to only ever using your sum formula when given a series. We now need to decide, of the 2 formulas that we know we have that deal with geometric patterns, so the TN formula and the SN formula, which one is going to be most useful to me right now? Well, let's think of it in terms of what we have. So I've got A. I can work out R quite easily. I don't have the sum, that's what I'm wanting to find, but I do have the value of my last term. I know that the value of my last term is that 256. And so because we have a term value, that's really, really important. Because we've got a term value, we are going to first need to use our TN formula in order to figure out how many terms there are. So we know that 256 is the value, so our TN value, and so that is the formula we're going to use. Now remember, that formula, I did write it down for you earlier, but that formula is TN is equal to A times R to the power N minus 1. So that is what we're going to use right now. We know the value, as I've just said, 256. is equal to A, which is this 0.25. If you write it as 0.25, if you write it as a quarter, makes absolutely no difference. It's completely up to you. I personally prefer a quarter, but it honestly makes no difference. Both are correct. Times, now we need the R value. Now guys, remember, in order for us to work out R, we need to take term 2, which is 0.5, and divide it by term 1, which is a quarter. And that gives us an R value of 2. And so now we've got a quarter times 2 to the power n minus 1. And remember, because we are trying to figure out what n is, which term it is, we are solving for that unknown in the exponent. Alrighty, so now we go and solve this equation. The first thing that I'm not a huge fan of is the fact that I've got that quarter there. Now, because it's a quarter times the base, I can just divide both sides by a quarter, because that gets rid of that fraction, inverse operations. And as long as you remember to do it on both sides of the equation, you have got absolutely no problems whatsoever. So what you end up with is 1024 is equal to the power n minus 1. And now remember, we spoke about this when we did geometric sequences earlier. But when you're solving an exponential equation, whoops, let's try that all again. What your goal should be is to make your bases the same. Exponential equation. We want to make our bases the same. So can anyone tell me what I can write 1024 as a base to the power of something so that my bases are both 2? So 2 to the power of what is equal to 1024? Nice, guys. Well done. 2 to the power 10. Excellent. Once my bases are the same, I can equate my exponent. So 10 is equal to n minus 1. And please, please remember, you are only equating the exponents. The bases are already equal. We have sorted that out. We now have to get the exponents equal for the equation to be true. And so what we get is that n is equal to 11. Now remember, we haven't actually answered the question yet. All we've done is we've worked out how many terms we have in our series. That's all we've done so far. The actual question is asking me to calculate the sum of the following finite geometric series. So now that I know how many terms there are in my series, I can go and work out the sum. Oh, and of course, I've left myself no space, so we're just going to do it on the side here. Right, so in this gray block on the left, we're going to do our sum. S and n is equal to A, which we know is a quarter, times R, which we worked out to be 2 to the power 11 minus 1, because remember, we've worked out that it's 11 terms that I'm adding, all over 2 minus 1. So I'll give you a second, put it in your calculator, let me know what the sum of these 11 terms is. Tender, I got something a bit different to you. I got 500 and oh, okay, cool. I panicked there for a second. I thought I did something stupid. Right, so guys, it is 2047 over 4, or the 511,75. Remember, both of those are absolutely fine. Whichever you prefer, it is completely up to you. I would probably go decimal in this case, but whatever it is, you're going to get the mark either way, so don't stress yourself too much about it. All right, so the takeaway from this example is that I won't necessarily always give you how many terms you're adding together, but I might still expect you to add them. And so what you would need to go and do is you would first need to figure out how many terms, are in the series that you are working with before you actually go and find the sum. And so always take very careful note of what information have you been given. Can you essentially go straight to your answer, or do you need to do some working out first? And in this case, I knew I couldn't go straight to my sum because I didn't know how many terms I was adding together. That was the first bit of information I needed to find before I could do anything else. So guys, with sequences and series, I'm going to say this quite a few times, it is so important that you read your questions carefully. Reading your questions carefully and reading your questions properly is going to be half your battle when it comes to these questions. And as I said to you at the start of this course, this is a really nice section to bank marks. It's only about 15 or 20 marks, but if you can do it well, it's 15, 20 marks that you are guaranteed in finals. So always read your questions carefully, do it methodically and do it slowly so that you can bank on those marks. All right, I'm assuming we've got screenshots, so I'm going to move on to example 4. And example 4 is saying the sum of the first n terms in the series, 3/4, 3/2, 3, so 3/4 plus 3/2 plus 3 plus etc., is 23 1/4. So I'm adding up a whole bunch of terms, and once I've added up those terms, this is my sum. So again, reading our question carefully, what we've actually been given here is an S of n value. I have no idea how many terms I'm adding, and so this question therefore makes a lot of sense. It's saying to us, determine the value of n. So this question is asking us, how many terms are we adding? So it's very similar to what we just spoke about, except for the fact that you have now been given the sum. So in the last question, I didn't give you the sum, but I did give you the value of the last term. In this question, I told you the sum of the series. We just want to work out how many terms I'm actually adding together. All right, so because I have been given the sum in this case, I can use the sum formula. That's information that I have. There's our sum formula. And we are going to substitute in what we know. So we know what the sum is. It's 23 1/4. I'm just going to write that as 23,25. If you write it as 23 and then the fraction of quarter, fine. If you want to convert it to improper fraction, fine. We have a calculator, so whatever makes it easier for you. Right, we know what A is. Remember, A is your first term. So we know A is 3/4. We can work out R because remember R is term 2 divided by term 1. So R would be 3/2 divided by 3 1/4. And so R in this case is, let's hope I can do math properly here. Is 2. Okay, so we're taking term 2 and we're dividing it by term 1. And so R is 2 to the power of n minus 1 all over R, which is 2 minus 1. Now again, grade 12s, be mindful of what it is you're trying to solve. We're trying to solve for this exponent. So because it's going to be an exponential equation, it's going to be very similar to what we did earlier. Now, in terms of the denominator of this fraction, 2 minus 1 is 1. So the equation we're working with is 23 1/4 is equal to 3/4 times 2 to the power n minus 1. And so this is what I was saying. This is very, very similar to the question we've just done. I'm not a huge fan of that 3/4, so let's divide both sides by 3/4 in order to get rid of that fraction coefficient. It's now gone. I don't have to stress about it. And when we divide both sides by 3/4, I end up with 31 is equal to 2 to the power n minus 1. That minus 1, I'm going to add 1 on both sides, so I actually end up with 32 is equal to 2 to the power n. And then again, goes back to what I said earlier, we want to make our bases the same here. That is the whole point of an exponential equation. So 2 to the power of what is equal to 32? Who can tell me? 2 to the power of what is equal to 32? To be so nice, 2 to the power 5 is equal to 2 to the power n. And so therefore, I'm actually only adding 5 terms in this series in order to get a sum of 23 1/4. But the important thing here is because I was given the sum, I could use my sum formula. And so this goes, again, read your questions so carefully to make sure that you are actually using the information that we've given you in the correct formula, in the correct method. What you guys need to remember is that we don't give you useless information. And this is particularly true when we get to like geometry. Everything that we give you has a purpose. It needs to be used. We never give you information that is not to be used or that is useless. So same as questions like this. I've given you the sum. Use it. All right, guys, let's take our screenshots there. And then same thing, you're going to try by yourself. There's an easy and a medium again. You decide which one you're more comfortable with. The easy does have 2 parts to it, whereas the medium only 1 part, but you decide which you are more comfortable with. Just going to wait for the screenshots and then I'm going to move to those examples. Okay, let's see. Right, so these are your 2 you try questions. Like I say, one is easier, it's got 2 parts to it, whereas the medium has 1 part only. Again, ask me questions. Let me know if you're struggling. You are welcome to just unmute yourself. You can put it on the chat, whatever you are more comfortable with. You can also direct message me if that's what you would prefer, but let's try these questions here. I'm going to give you 5 minutes to do that, and then we'll have a look. I'm going to mute myself so I don't disturb you. Remember, guys, you can put your answers in the chat to help out your classmates. Remember, guys, I give you these to try by yourself because obviously it would come a test or an exam or whatever, you need to be able to do it yourself. So it's really important that you are giving it a try, and when I put up the answers, correcting if you got anything wrong and giving yourself a big pat on the back when you're getting it right. Obviously, if you finish the one that you're on, please do go ahead and do the other one. Extra practice is always good. I'm going to give you another minute or two, and then we'll have a look at our answers. Okay, grade 12, let's have a look. All right, so if we have a look at the easy one first, your two questions here. The first was asking you how many terms were there in the series. So you use your TN formula, just like we did in the example before, example 3. And then question B was asking what is the sum of the series. So because you knew how many terms were in the series, you could then go and work out the sum of the series. So there were 12 terms, which means that you needed to add the first 12 terms together. Right, if we go and have a look at the medium question, the medium question, you had a geometric series and I told you what the sum was, and I wanted to know how many terms was I adding together in order to get that sum. So if you go and do, and it's basically example 4 that we had just done, if you go and do exactly what we did, you go and get that you add 12 terms together in order to get the sum of 20,475. Okay, so take your screenshots, guys. And then we'll have a look at our next example. Alrighty. Okay, so if we have a look at example 5, this one's a little bit different. So we, again, need to read our questions really carefully so that we actually know what's going on here. Right, so the question says, in a geometric sequence, so it's telling us exactly what the sequence is. In a geometric sequence, T1, so term 1, is equal to 1, and T4, term 4, is equal to 27. Determine the sum of the first 10 terms. Now, the problem, what's different here is that I haven't actually been given the series. I've been told specific terms, but I have not been told the series. So I don't actually know what terms I'm adding or subtracting together. But remember that when it comes to our sum formula, the only bits of information we need are the first term, which I've been given T1, as well as my R value. So I have my first term, what I don't have is R. And so we now need to figure out how can I get R in order for me to be able to go and solve for the sum. So if we think about what we have been given a term position and a term value in each case. So I know term 1, the first term, is equal to 1, and I know term 4, the fourth term, is equal to 27. So if I go back to my TN formula, I can use that information to my advantage. I'm going to sub in both, and then we'll discuss which one we'll use. But if I go and sub in for term 1, so the value of term 1 is 1, which equals A, which we know is 1, times R to the power N, which is the first term, minus 1. I'll come back to that in a second. If I go and sub in term 4, 27 is equal to A, which we know is 1, times R to the power 4 minus 1, because it was the fourth term. So all I'm doing here, guys, is I'm taking term 1 and term 4's information that I was given, and I'm substituting it into my TN formula. That's it. Okay, because I know what TN is, I know what A is. All I don't know, and I know what N is rather, I don't know what R is. And remember I said right at the start of the question, the only thing I don't know in order to get the sum is the R value. So if we go back to where we substituted in the value of term 1, what I want you guys to see is that this exponent, 1 minus 1, actually becomes R to the power 0. So we've still got everything else there, but this R to the power 0 is what is the problem for me, because we know that anything to the power of 0 is 1. So this all actually just simplifies to 1, and that's not helpful for me. I want to find R. So I'm not going to work with that term 1 value, and you will see this will happen every time you try and substitute in term 1. But if we go over to term 4 which was 27, we are going to be able to solve for r. Because what we see here is that we've got 27 is equal to r cubed, because this coefficient of 1 doesn't do anything. 1 times anything is still that value, so it doesn't do anything. And we know that 3 cubed is the same thing as 27. My exponents are the same, which means my bases must be the same. And so we can see that r is equal to 3 here. And now we have got our r value for our formula. All right, so what I want you to quickly do for me is, now that we know what a and r is, I want you to substitute in, and I want you to tell me what the sum of the first 10 terms are. Remember, you can put it in the chat when you've got an answer for me. Okay, so guys, if you substitute in, I'm liking these answers that I'm seeing. Very nice. Samtanda, Brenda, Brooklyn, nice guys. Alrighty, so if we substitute in, we get 1 times 3 to the power 10 minus 1 over 3 minus 1. Obviously, you don't have to put that specific a value there because it's 1. It's not going to change anything. But you chuck that into your calculator and you get that the sum of the first 10 terms is equal to 29,524, exactly as you guys said there on the chat. So with this question, again, it comes down to reading your question carefully. Please remember that when you're given the value of a term, so that 27 and that 1, you can substitute it into your TN formula. As long as you know which term it is, you are then able to solve for your A or your R, depending on the information. In this case, we needed to solve for R. And then you can easily work out what your sum is because you have all of the information that you need. So guys, I can't stress this enough. Reading your questions carefully is so, so important.